Let's talk about consistency in our SSIS packages. And we're going to talk about consistency from two different perspectives. We're going to talk about consistency by using transactions, and we're going to talk about checkpoints. First of all, how do we deal with package failure? So when the package just simply utterly fails, how do we deal with that? And then how do we, and this may sound odd, but how do we cause that to happen? How can we control that failure? Well, there are three different properties that we can use to control how failure works. Fail package on failure, fail parent on failure, and maximum error count. Now, we've already talked a little bit about maximum error count. It's simply a property you set, and you give it a number between 1 and whatever. And that number represents the maximum number of errors that can occur before a failure. Now, by default, that's set to 1, and that would normally stay 1. In other words, if there's 1 error, we want the task to fail. But we can set it higher. Honestly, it's not my recommendation. Unless you really know what you're doing, setting the maximum error count higher than 1, you think you know what's happening, but the errors that are occurring may not be the errors you anticipate. So I'd recommend some other ways of dealing with that, and we'll talk about those later on in a different module. But I do want to talk about fail package on failure and fail parent on failure. First of all, let's define what a parent is and what a package is. So if I have a package, and I'll just draw that, and on that package, I have, let's say, a container. Doesn't matter what kind, sequence, it doesn't really matter for this discussion. And then in that container, I have several tasks. Now, thinking from the tasks point of view, its parent is the container, and the package, of course, is the package. From the container's point of view, from its perspective, the parent is the package itself. So for the container, the parent and the package are the same thing, unless we have another package that is running this package as an execute package task, in which case this package's parent is the package. And so you can go on up from there, but you can have this kind of infinite digression, and I don't want to do that. But just remember the difference between what my parent is and what my package is dependent upon what level you're at. If you're the task inside the container, inside the package, then your parent is the container, the package is the package. If you're this container, the parent and the package are the same thing. So what we're describing here is what happens when certain options fail. So if my task fails, what do I want to occur? Do I want the entire package to fail, or do I want just the parent, my container, to fail? So you can control that way. We also have transactions that we can use. Transaction options are basically, there are 3 ways to set them, and I'm assuming that you know what a transaction is normally in T-SQL, and so I'll just build on that. But when you look at an individual task or a container or a package, there's a property called transaction option, and it can be set to any one of these 3 possibilities: required, supported, not supported. If you set it to required, what that means is this object, whatever it is, task, container, or package, requires a transaction to be running, and if none exists, it will create one. It will begin a transaction if there's not already one. And if there is already a transaction, it will join it. It will just be part of it. Supported means that if there's already a transaction, in other words, let's draw this again. So I have my task. Let's just keep it simple. My task inside of a package. If the task is set to supported, then if there is a transaction already running because of the package, this task will participate or be part of that transaction. But if it's not, if there is no transaction already started, it won't start one. Whereas if it was set to required, it would start one. And then finally, there's the not supported, meaning I don't really care whether you are a transaction or not, whether it's already started. I will not be part of your transaction. I won't create my own, and I won't be part of a transaction. It's a standalone kind of a thing. Questions about any of that? All right, so let's see that in action. So I've got set up here a project and a package in that project, and it's pretty straightforward. Before we get into it, let's just look and see what it does. We have a data flow task, and it reads from a staging table, dbo.staging table in the demo DW database. And it writes to a destination, which is simply another location in the demo DW, in this case, the production table. And when that's done, it runs this SQL task, which updates the prices. So it's going to simply update this table and set the production or the price equal to 100 divided by price. That's all this really does. Let's take a look at what's in those tables first. And let's take a look in the demo DW. Let's look at the tables, and let's look at the staging table and see what's in there now. There are just these 3 records for a blue bike, a red bike, and a black bike. Now notice their price is set to 0. That's going to cause a problem when we try to divide that into 100. We get obviously a divide by 0 error. Let's look at what's in the production table right now, and the fact is there's nothing. Okay, so let's go ahead and take a look at this, and let's run it. We know there's going to be an error. Interesting. That is an error, but that's not the error I was thinking of. Exception deserializing. Okay, let me close this then and reopen it. Let's try this again. Well, that's not good. So what do we got here? Exception is deserializing. The file contains corrupted data. Well, okay, let's close this. See if I can open up a different one. Just want to try experimentally to see if this one runs, and it does. Okay. I'm going to have to close this lab and reopen it. So bear with me just 1 second. Okay. Well, let's go ahead and look at some more slides. No sense in staring at the screen while it builds. Let's take a look at some other things and we'll come back to it. All right. Let's talk about checkpoints. So I want you to picture a scenario where you have a package that runs every night at, midnight, whatever. And what it does is it goes and runs an FTP task and downloads a very large file from a vendor. And then after that, it shreds that data into your tables. And those two processes together take, 3 hours. Then when it's all done, it does 2 extra things. It deletes the file, because I don't want to have it there for tomorrow night. And then it sends an email off to the appropriate people to tell them that this has been completed. So tonight, when it runs, there's a problem. It downloads the file just fine. It does the shredding, but when it goes to delete the file, something else has it locked and it can't do the delete. So you've got the majority of everything done. You just don't have the last 2 little tidbits done. You haven't deleted the file or sent the email. Tomorrow morning you come in, you notice that. What are you going to do? Well, Okay, you can go manually delete the file and then send the email manually. You could also rerun the package, but the last thing you want to do is download that file again, and you sure don't want to write that data into your table. Now you've got duplicate data that we don't want. So what checkpoints do is they allow you to have a recovery point in your package so that your package starts at the place where it failed. In other words, it would take a look and it would see that it completed task 1 and it completed task 2, and now it's not ready to do task 3, the deleting of the file, and it would start right there. The way it does that, it creates a file, creates a text file, and in that text file, as things run and complete successfully, it records that this task completed, along with its state information. It completed with errors, without errors, any variable information, the value of any variables, parameters, etc. It does the next task. It documents that in the text file, along with all its state information. And then the package fails. So this file is now sitting there. The next time the package runs, assuming we've configured checkpoints, the next time it runs, it reads this and it says, oh, these first 2 tasks were completed successfully the last time it ran. Therefore, I'm going to skip them and go straight to whatever the next task in order would be, the deleting of the file. On the other hand, if the package runs successfully and all 4 of my tasks run and there are no errors, then when it's all finished, it simply deletes the file so that the next time it starts up, it looks for that file, it sees that the file doesn't exist, and therefore it knows to start from the beginning. If it did exist, it would read it and start from wherever it left off. So that's kind of what checkpoints are and how they work. Let's take a look at the settings that you can set. There are 3 settings for checkpoint. The first one is save checkpoints. Save checkpoints basically is turning this on or off. If you save checkpoints is a true false kind of situation, you either set it to true and it turns on this whole process, or you set it to false and it doesn't. The default is false. Checkpoint file name is simply that, the file name of that text file, including the location where it's going to be. And then checkpoint usage is a little weird. Got to be honest with you, this one throws you. So there are 3 possible settings for checkpoint usage: always, never, and if exists. Always, if it's set to always, it means that it will always look for that file, the existence of that file. If the file doesn't exist, the package will fail. Honestly, I can't think of a reason why you'd want to do that. I'm sure that somewhere somebody needs that property setting, but I've never figured out why you would want that. So it could be always. It could be set to never. If it's set to never, it will ignore any execution files or any checkpoint files. In other words, it may exist, but I'm not going to read it. I'm not going to take care. I'm just going to start the package from the beginning. Again, I can envision a few situations where you might want never, but I've never used it. Checkpoint usage, in my experience, is always set to the 3rd option, if exists. In other words, if that checkpoint file exists, I will read it and pick up where I left off. If it doesn't exist, it will create one and start reading it. In any of these settings, when the package finishes, it will delete that text file if it still exists, if it's there. So that in theory, at least, each time you start a package and it has checkpoints enabled, it will look for that file. If it exists, it will pick up where it left off. If it doesn't exist, it will create it, run through, and if everything goes successfully, it will delete the file when it's done. So that's how you set checkpoints and how you avoid repeating steps that are already finished. So let's see if that started up yet. It did. Good. Let me get logged on.
I was going to say, sorry for being late. My morning meeting ran way over.
Hey, no problem. I understand. Actually, a lot of people were late. I think John was about the only person that was here right on time. So we'll, no worries. Okay. So let's go back to that transaction before the checkpoints, the solution for transactions. Okay. So once again, just to review, this package is going to read from the staging table and write to the production table. When that's done, it's going to update the prices and everything, and it's going to divide it all by 100. Or, sorry, divide 100, or let me start over. It's going to set the price equal to 100 divided by price. Now, I don't know why that doesn't make any sense, but the whole point is it's going to fail because when I look at what's in the staging table, you'll see the price for each of those is set to 0. So if I look at demo DW, the only table in here that we can look at, production, or a staging table rather, you'll see the prices are all set to 0. So therefore, when we try to divide 100 by the price, it's going to fail. So let's execute this and hope it runs this time. No. Okay, never mind. I'm not going to be able to show this demo to you. But basically, what I would show you if I could make this run is clearly this is going to fail, and we want to set it up as a transaction. So we can look at the properties of this. I'm going to make this a little bigger here. And I can come down to the transaction option, and I can set it to any one of my properties. Right now it's supported, meaning if the package has a transaction running, it will be part of that transaction. So let's see what the package itself is set to. The package is set to supported, meaning if some package above it called it, it would support that transaction, but it wouldn't start one. So in other words, in order to make sure that this is a transaction, we would have to either for the package or for this task, set it to required, one or the other. But I'll show you what I prefer to do. Move these out here a little bit. You can do that and it works perfectly well. I think it's a little less documenting. So what I do instead is I get my, oh, and by the way, if this ever happens to you where your SSIS toolbox is missing, you can just come right over here and click this button. I don't know why they hide it. It's kind of not very obvious. And if you're not used to it, you spend hours looking for how to open the SSIS toolbox. But it's that button right there. So let me show you how I deal with transactions. So I'm just going to simply create a pair of execute SQL tasks. And you can probably guess what I'm doing here. I'll simply connect them up this way. I'll come in here and I will just begin tran, create a connection. What database are we looking at? Whatever. Yeah, this package, sorry, this package is apparently really messed up. But you can guess what's happening here. What I would do is I would just create an execute T-SQL statement task that begins a transaction and then one that commits the transaction. I don't know exactly why this is going on, but it is. But you can see that it would accomplish the same thing. It surrounds these two things with the transaction. The only reason I like this better is it's a lot more self-documenting. It's a lot more clear to someone coming in looking at it than it would be to look at the transaction option property. And that it makes no difference. So I apologize for this project actually. Let's open a different one. Let's open up the one for checkpoints and hope that one goes better. Okay, so now in this package, we're going to have a file system task that's going to create a folder. It's going to create a directory, and it's going to use the connection down here. So it's going to create a folder in the mod7 folder called data. Right now, there isn't one. Then it's going to copy a file. So it's going to simply copy a file, the products.csv file, into that folder. And then finally, it's going to run a data flow task that will read that file using a flat file connection manager. It's going to look for that file, products.csv, and that will be my source. I'm going to add a couple of columns, new product name and new price. Again, notice what we've got here. This is going to be the source of our error, 100 divided by price. And the price is going to be set to 0, so we're going to have a problem there. And then finally, it's going to load that into our staging table. So when we execute this, we run into a problem right away. And we can look at the progress here and see divide by 0 error occurred. So let's stop this. And now let's take a look at our checkpoint stuff here. So for this package, I can come over here to the properties and look at my 3 settings: checkpoint file name, checkpoint usage, and save checkpoints. So let's first of all set save checkpoints to true. We're going to do our checkpoint usage and set it to if exists. And we're going to set the checkpoint file name to demo files mod07 / checkpoint.chk. It doesn't matter what you name the extension. I usually do use chk just because it's obvious what it is, but you can make it whatever you want. All right, so we've turned that on, but let's come out here and look at this now. It's created that folder and created that CSV file. Let me just open it up real quickly to show you that price error. Okay, so what I want to do now is start over. So I'm going to delete this folder. And now that we've turned on the checkpoint, let's give it a try again. We haven't fixed the error now, but let's fix this. It should run, or not fix it, but let's run it. We're going to encounter the same error. We get the same divide by 0 error. When I go look out at my folder, once again, it created the data file. But look here, where'd it go? right, let me change this. Let me do something different here. Okay, now let's execute. Oh, I think I know what's happening. Hold on. All right. So here's what's happening. Interesting. This is failing, but guess what? If I look at my progress here, my package actually doesn't fail. That one task fails, but the package didn't fail. So let's stop this. And let's look at the properties of this data flow task. And we're going to look at the fail. Yeah. Okay, so fail package and fail parent are both false. So that was behaving exactly the way it was supposed to. Now I've set the fail package on parent or fail package on failures to true. And in this case, the package and the parent would be the same. So I could actually have set either one of these. It wouldn't really matter. Now let's run this again. Again, it's going to fail. Same error. If I go out now, that file exists. If I open that up, let's use Internet Explorer. It's an XML file, and that was a bad choice. Let's open it up with Notepad then. And it's not particularly easy to read. It's an XML file, but what we're looking at here are the package ID, is an internal ID number, the variables and their state, any containers, and each of the tasks. And this is listing for you all of the things that succeeded. Now, fortunately, we don't have to go read that file and look at it. It just has to be there. All right, so let's stop the package from running. The checkpoint file is created. And if I go back to demo files, mod 7, my data folder is there, and that file's copied into it. My problem, obviously, is not with copying the file. It's with doing this, the derived column. And the problem is it's trying to divide, set new price, this new column, equal to 100 divided by price, which is 0. So instead, let's just fix the problem. I'll cheat and make it easy. I'm going to make everything equal to 100. That will solve the problem. But now what I want you to do is watch what happens when I run this again. Everything now succeeds. But back here on the control flow, notice what it didn't do. It didn't do those first two steps because the checkpoint said there's no need to do them. The folder's already created, the file's already been copied, and all we need to do now is load them. So we've got all the steps going right, and it was able to start all over without having to redo these two phases. And that's what the checkpoints are all about.